Okay, so this is lab number 2. I'm going to go ahead, go over the solution guide to this so that everyone can understand how to go through each part of this. I'm going to go ahead and do this on IntelliJ. So if you want to go ahead and follow through with me, if you need any help or kind of just skip forward the parts that you're a little stuck on, and then hopefully you can get this finished if you haven't already. All right, so the first thing we're going to do is write our own algebra class. The class should have the following static methods. So we're going to have to create a double. That is average, so we're returning a double right here. This is a static. All these are going to be static methods here, which means we don't need to make an object to use it. We can just go ahead and use it. This one will get the average of two numbers. This one will get the slope of 4 points. This one will get the difference of two numbers. This will get the square. And really, we're doing the difference and the square so we can calculate distance. And distance is going to be that Pythagorean theorem, the distance equation here of the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so we can go ahead and find the difference and then square them, add them together, and then we'll do math dot square root to get that, and that should get us right here. We're also going to be doing this scanner input. So enter 2 points in the plane. It will prompt them what to enter right here, and then we'll spit out right here the slope of the line through A and B is here. The distance between them is this, and the midpoint is here. So that's what we're going to kind of use to get all this information out of it. So go ahead and open up IntelliJ. We're going to create a new project. I already got lab 2, so I'm just going to create a new one. We'll call this lab 2 solutions. I think this is the one we started, kind of get you going here in class. I got my new project here. Make sure you got Java clicked right here. We got our SDK. If you got the latest, it's probably 16 right there. Go next. We don't want a template. We're going to scratch here. I'm going to call this lab 2 solutions. And we're going to click finish here. And we should get this pulled up. There should be some tabs to the left right here when it gets going. So I'm going to click on this project on my left side right here. It's giving us tip. We can just go close that. Okay, so it looks like there's nothing here, but we need to go ahead and create a new class file. So I hit this tab, and I got right here the source code. So I want to click that, right click, so I can go ahead and get this pulled up. And I want to make a new class. This is my Java class. And let's go ahead and name this. I'm just going to call this one my algebra test. So this one will actually test my algebra. And then my other one will be my algebra class. So once I go ahead and make that, so in my algebra test, I'm going to go ahead and put my main method in here. So just do main tab. That will go ahead and do this. This is our driver method. Everything will run from this one right here. Okay. If you want to make sure you have it set up properly, we can just go ahead and do it real quick and just do a system out print line. Hello. Okay. I can pull up my terminal to see where the output's going to be. And I'm just going to click this triangle right here. And then if I look down here, it's going to go ahead, hit run there. It's going to compile it first, build, and then it will go ahead and run it right here in my terminal. So first it has to build it, compile, and then it will run. Just give it a second here. Okay, there we go. So print out here exactly what I want. Okay, so this is where we run everything from. Remember that everything is run from this main method right here. Now I actually am going to create my algebra class, right? This is just what I'm testing it with. I want to make my own file for it. So go right over here, and I'm going to go new, Java class, and I'm going to name this one algebra. Now the nice thing inside IntelliJ is it automatically will save this as a .java. When we were doing this in Repellent, we had to make sure that we added a .java to it. As long as I just put the name of it, it will go ahead and do that inside of here. So I want to go ahead and I have this right here. So my public class algebra. Okay, so now I got this all set up exactly how I need it. These are all static methods, so I don't actually have to create any constructors here. If I have this being non-static, then I would need constructors, but I don't. So I can actually just go ahead and start coding my algebra class right here. So I'm going to go back to my sheet and let's see what the first one it wants us to do. The first one is given two integers, x and y. return the average. So this is what we want it to be right here. So I can actually, I'm just going to go ahead, copy paste this, make my life a little easier. That's what my header is going to be. So I'm going to paste that right here. Public static double. So just to be clear, this is a static method. So it's telling me I don't need to go ahead and have an object. It's returning a double, and the name of it is average. I have my parentheses, what parameters I want to go into this. So I just am putting 2 integers inside of this. After that, I need my curly brackets. Every method needs to start and end with a curly bracket. So I have that right there. And then I'm just going to return here the average of these two. So what's the average of 2 integers? Well, that's just x plus y divided by 2. And that's my average right there. Okay. That method's done. Okay. Again, pretty straightforward. I just got to make sure I have the name of the method in there. Public right here. Static meaning it can run on its own. I just have to call the algebra class to run it. And then double, that's what it's returning. Name of the method, average, integer x, integer y, and then I do the average right here and return it. All right, let's look at the next one. So the next one here is we want to find the slope. So given 2 points, return right here, returns the slope of the line through them. So again, I'm just going to copy this right here. I'll go back to my IntelliJ, and I'm going to go ahead and put this in here. So public, this is just making sure I can access it right here inside of here. Static means I don't need an object to run this. Okay, double is what it's returning. Slope is the name of my method. Here are my formal parameters that will be needed to run this. So I'm taking in 4 different integers. I'm returning a double here, and then I'm going to do a curly bracket. And then I'm going to go ahead and find the slope of this. All right, so the slope, if you remember our slope, that's going to be, first let's just make this a double here. Sorry, I'll return there. All right, so slope is the change in y over the change of x. So if I do this right here, I would call this y2 minus y1 divided by x2 minus x1. Okay. Now the only tricky thing in here is these are all right here integers. I want to get a double out of this. I want some decimal point here. At some point, I'm going to have to cast this. All right. If I cast this before any of my multiplication, I won't get any decimal point. It will go ahead and do an integer calculation, and then it will return to me and turn that integer into it. If I want to get a little more precise here, I'm going to have to cast before that. So I might go ahead and cast this y2 to a double here. So I might go ahead and do a parenthesis double, and that should go ahead and return y2 to it. And let's go ahead and do same thing for x2. And then the reason why I want to go ahead and do those two, so it's going to do what's in the parentheses first. If I turn this to a double, then this whole thing will become a double. And then I want to treat this as a double as well. So it's a double and then double divided by double, and I should be okay right there. As long as I don't have too many parentheses going on here, I think we'll be okay. I think we're okay. Let's go ahead and create a, go to algebra test. I got 2 of the however many I need. Let's go test this though. So what I really need to do is I want to go ahead and pull in info from the user. So it says go ahead and import values in. So I'm going to use the scanner. To get the scanner, the first thing I have to do is I have to import it up top in my algebra tester here. So I'm going to go import java.util.scanner, and that right there. So this goes ahead and this is just importing the scanner for me. And then I want to create the object scanner object. Okay, so I come right here, and I'm going to go ahead and go scanner right here, give the object a name. Let's call it points. That's what I'm getting here. New scanner, and this time I want it to be system dot in. Second there to catch up. Okay, so what this is creating a new object, and I can then read off of what is put into the terminal right here. So I'm then going to create 4 points. So let's go ahead, integer x1, x2, y1, y2, and that was a semicolon. I went ahead and just declared all those. Then I'm going to prompt the user to go ahead and enter a value for x1. So I'm going to go system.out.println, enter x1, semicolon space right here. And now I want to actually go ahead and get that. So I declared x1, and I'm going to go ahead and do points. That's the name of my object. Dot next int, capital there with the I, and then I'm going to put my parentheses and a semicolon right here. Okay. Now I'm going to do the same thing for each one, right? So that just gets the first one. So system.out println. I'm going to do it like it would be a point. So I'm going to do enter y1. All right. So if I'm looking at a graph here, it's entering in point by point. So y1 equals points dot next int. Let's go ahead and get the second point from my graph here. Two equals points next int. And last one here. Two. I've got something red here. I think I switched. Let me finish this and I'll go back up and look at that. Points dot next int. There we go. All right, so I'll come back here and I switch my T and my N. There we go. That should fix my error. Okay, so this should go ahead and get those 4 points from the user. Now let's go ahead and so this is just getting those points in. Now I want to test my algebra class here. So let's test average and let's test, well, first let's just test the average. Okay, let's see if we get any errors here and then we'll figure out what the errors are. So if I go up and I test average, so I'm going to do system out print line, and let's do average. So I'm going to go ahead and do algebra. I got to call the class name dot average, and I'm just putting in 2 points here. So I'm going to do it of let's say x1 and x2. Let's find the average of here of these two. Okay, so I'm going to go ahead and run. We'll see if we get any errors. All right, so we got an error right here, line 7. It says it is expecting an extra parenthesis, and I don't have that. So let me go ahead and add that right there. Okay, let's try and run this again. Go to my algebra test. Go to my terminal. Okay, so good. It went through. Now it's asking me to prompt. So let's put my first position is, let's go 0. Enter y1. Let's go 0. So let's start our first point at the origin. And then enter x2, 3, and then 4 here. Okay. Well, so I took the average right here. I ran average of x1 and x2. So x1 is 0, x2 is 3. So the average right here should be 1.5, right? But I got 1. So what's going on? Well, I probably did some integer evaluation here, right? It's returning a double. But notice here I'm putting an integer. I need to convert one of these to a double. Use a little casting here. Let's just convert this first one to a double, and I should then get 1.5 here. Again, if I do an integer plus an integer divided by an integer, I'm just going to get an integer out. So I lose my decimal place. I'm returning a double here, which is what I want, but I'm not getting a double because I'm just doing integer evaluation inside there. So if I cast this to a double inside there, this should fix my problem. Let's try this again just to make sure. So I'm going to start with 0.00 again, and let's go 3 and 4, and there we go, I get 1.5. So that's really important here. I overlooked it when I first did it here, but we want to double out of this. In order to get a double out of this, I have to cast one of these to a double. That's exactly what I did here too, right? I cast these to a double at this point. So if I want to find the slope of this, we can go ahead and find the slope of this as well. I feel pretty confident though. I'm just going to go ahead and keep programming the rest of this right here so that we can go ahead and finish this up here in a reasonable time. So I'm going to go to my next method I want to create here. And the next method is going to be the difference. So given two integers, x and y, return the difference. So let me just copy this. Go back to my IntelliJ here. And paste there. So this is just the difference. I make sure I got a curly bracket beginning and end with. When I make one, it makes the finish. So I just push enter, pushes it down, and I got it right there. Okay, so this is want to return it as an integer. Okay, I know that because that's what it's saying right here. Remember, public, this is a static or non-static. If it's non-static, it just doesn't have anything here. This says static, which means I don't need an object. What is it returning? This is my return type, integer. The name of the method, difference. What am I putting in? I'm putting in two integers, and I'm going to call those x and y. So here, I'm going to go return the difference of x minus y. Done. That's a pretty straightforward one. Okay, next. Go back here. Square. Okay. Given an integer x returns its square. So we just want to go ahead and square it, and we're returning it as an integer. That's nice. All right, so let me get this one. Come back to IntelliJ. Okay. Now I only have to put one variable in here because I'm just squaring it. And then I'm going to go ahead and do return x times x. There we go. I could do the math power dot power and then put an x and then 2. That would be fine, but there's no need to. I can just do x times x is, I think, almost as simple. All right, so that's my square. All right, then the last one I think I need to do here, I think we have all but given 2 points. Yeah, we just need to go ahead and do the distance. So let's pull this big bad boy in here. And then we're going to come to IntelliJ, and we're going to do our last one here. Now, if you're wondering why are we using the same values here, integer x, integer y, and we can use those for all of these right here. Okay, we haven't talked about this yet. We will get to this. It's called the scope, though, and these are called method variables, which means notice how we didn't define these variables for the class. They're just being defined for each method. That means these variables only last for the method. They don't last any longer than that. We could save them for the class, so I could declare maybe a class variable up here, and then inside here I said equal to. We've done a little bit of that. We'll get way more into this, but we haven't gotten into it yet. But just know that if I set x and y here, x and y is done after this method. So it's okay I reuse x and y here or x here because it's outside of this method. And then this x is completely different than this one, okay? In order for it to carry through the class, I would have to define a class variable up here. So that's why we can reuse it. We'll get way more into that, though, when we talk about scope and what variables can go to what. But just a heads up on that. All right, so my distance equation. If we need a review on the distance equation, we can do it quick. If you don't remember it, I can say it out loud. It's the square root of the difference squared plus the difference squared of x and y. But maybe let me just show you. Let me just pull it up real quick here to show you what I mean. Distance equation. Maybe you're a visual person. You need to see it real quick. That's it right here. That's what I'm talking about. Okay, so this equation, what we're doing is we're taking the difference of x and then squaring it. Well, we just made the difference method and we made a square method. So I'm going to run the difference method and then square it. I'm going to do the difference method here and square it. Then I'm going to add them. And then we're going to take the square root. So to do the square root, I'm going to do math.square root, okay? And then everything inside of this. So I'm going to make this just one big thing, and I can return it, and that'll be okay. But that's my goal here, all right? So if you're confused where this is coming from, this is the distance equation. Also, you can kind of think of this as the Pythagorean theorem, right? This looks about the same. For that reason, I have another example in there. I'm just going to use 0, 0 as my points and 3, 4 because I know a 3, 4 triangle is going to be 5, right? That's a pretty elementary right triangle right there that you learn in your basic trig class right there. Is that a 3, 4, 5 triangle? So I'm going to go ahead and use those as mine, and I'm going to go ahead and program this here now. Okay, so I'm returning a double. I'm going to go return. And I know that it's going to end with math dot square root. Okay, so it really just put something in here. Okay, that's not a big deal. So I got the first part. So then I want to square the difference. So I'm going to go square the difference of x2 and x1 plus square the difference, and I need to write all the difference, don't I? Yeah, it has an issue with that here. So difference, that's I got to use the method name. And when I made the method name, I used the whole thing. So I got to use the whole thing right there. Y2, Y1. Boom. And let's end that there. And let me fix this. Okay, so now I have the difference of these two. All right, so I find the difference, I square it. And I have this square method right here. I find the difference and I square it. And I add those two parts together, and I get my math dot square root to give me my answer here. And this should give me the distance equation. I know this should work. Then if I get 5, that comes out of here. Now, there's a special format at once, so let's try and follow this special format in our algebra test. I'm going to come back here. It says, first, given the points. So given the points, let's go ahead and write that out. We'll do a system dot print line for that. So let's start there, given the points. And so I'm going to come back to my algebra test. All right, so let's go system out here, and let's just follow this. So given, literal here, given the points, space, and that right here, and let's go, you know what, I'm going to put a parenthesis right there, and then I'm going to end that, plus, and then I'm going to go x1 plus, and put a comma, plus y1, and plus, and then another one right here, and I'm going to end my parenthesis. So that should put the first value, and then I'm going to have another parenthesis here. I'm going to end that, plus x2 plus, okay, so really just a lot of formatting here, plus y2 plus parenthesis right there, and let's end this and semicolon. So this just says, given the points, let's go put it in there, given the points, and then I'm just listing those 2 points, okay? Then the next thing it wants is, given those points, the slope. Okay, so let's just list out the slope next. System out. The slope is, and then I just need to go ahead and run the slope, right? So that's going to be, now at this point, I am outside of the algebra class. I'm in the algebra test class. So I need to call my algebra class at this point. So I'm going to go algebra. So to call it, I'm just going to put the name of it. Then I'm going to go dot. Now I can actually see everything I have here, right? All these methods I've created are now available to me. So I'm going to go slope. And then it tells me how to put it in, right? x1, y1, x2, y2. So I'm going to go x1, y1, x2, y2. Okay, and then I can go ahead and end this, and that should give me my slope. All right, next one, system.out.println. I think it's the midpoint here. Let me double check. The slope, okay, just the distance. Okay, the distance between them. So I'm going to use my distance one at this point. The distance between them is space right here. And then I can use my distance. So again, I need to call my algebra class, algebra dot, and then want my distance here. So distance, x1, y1, x2, y2. So x1, y1, x2, y2, and that one. And then my last one right here is, what is it looking for? Midpoint. Okay, the midpoint of the two segments. And then it's going to do it as here, midpoint of x, midpoint of y. Okay, that's not a big deal. We can do that. So we go system.out.println the midpoint of the two is space right here. But you know what? Before I put a space, I'm going to go parenthesis to start it right here. And I'm going to go plus, and then I'm going to go algebra. And then I created this average, right? So I'm just going to put in x2, x1. So I'm going to do average x2 or x1, I guess it doesn't matter, x2. That's going to be my first one, plus, then I'm going to put a comma here, and then plus, and then the same one again, but for now I'm going to find the average of the other one. So algebra average y1 and y2, and then plus, and then I just need to end my parenthesis. Do I have one too many here? I think I got one too many. Here, I got parenthesis there. One side. Okay, that should be it. Oh, it looked like I misspelled algebra here. There we go. Nice thing is it highlights right there. All right, so I think I got it all. I have no idea. Let's try and run this and see what happens. I'm sure there might be an error somewhere in here. Okay, I'm going to stick with the 0034 because I kind of know what those are all going to be off the top of my head. There's an example you could have run in there. I'm just going to use that. Oh, so no errors yet. That's good. So 0, y1, 0. Okay, x2, 3, and let's go 4 here. And here we go. So given the points 0, 0, and 3, 4, the slope is 1.33. That makes sense, right? Because rise over run, 4 over 3, 1.33. Perfect. The distance between them is 5, exactly what I expect. And the midpoint between 0 and 3 is 1.5. The midpoint between 0 and 4 is 2. Excellent. Okay, so this all works out. If you're submitting this, you can go ahead and zip these and turn these both in, or go ahead and turn this one in. Really, this is the main one I was looking for, or you can just turn both of them in. Hopefully, though, this made sense to you. If you have any questions, let me know, and I'll see you guys next time.